B.
All right. So this is a 2-day packet. We're going to be doing a lot of the notes together. We have done distributive property before, but this time it involved integers. But we're going to take this and what we're going to do on the next page, and then it all gets put together. Does everyone have one? Yes? All right. So this starts out with the distributive property. This is where you take whatever is on the outside of the parentheses and multiply it by everything on the inside. You're distributing it. And teachers everywhere love to draw the arrows because that way you don't leave out anything inside the parentheses. So we have 3 times D is 3D, and 3 times 4 is plus 12. The important thing that we're going to talk about today is the fact that whatever sign is in front of the number, whatever is before the number is what is attached to it. Because you read from left to right, so whatever's in front of that number is the sign that goes with it. So you don't see this a lot where the number is behind the parentheses, but it's still the same. It's still just multiplication. So we have 4 times W is 4W, and then minus 20. Here we have a negative 2 times C and a negative 2 times 14. I'm sorry, negative 2 times 7. I just said the answer. So what is negative 2 times C? Negative 2C. And a negative 2 times 7 is negative 14. So I'm just going to put minus 14 because, now listen, subtracting a positive is the same thing as adding the negative. And math is the exact opposite of English. We're in English class, and they want you to write a paper, and they want you to elaborate and develop the story more and use more adjectives and this and that. In math, we like things as simplified as possible. So although this is the same thing, why put 2 signs when you could just have 1? All right? So the more simplified, we try to get things as simplified as possible in math. Okay? Now, 9 times B and then 9 times 4. So we have 9B plus 36. And these are expressions. And these are equivalent expressions. This is the same thing as this. They're equivalent expressions. Just like this, and that are all equivalent expressions. All 3 of those are the same thing. Here we have 8 times P and 8 times negative 10. So what is my first term? 8P and then minus 80. Now, if you put negative 80 plus 8P, it's the same thing. But typically in math, we like our variable terms first and the coefficient, which is the, and the constant, which is that plain old 80 at the end. The negative 80, we like that at the end. Constants at the end. And this is a really good one to do because of all the negatives. You distribute this and that. What is negative 11 times G? Negative 11G. And then what is negative 11 times negative 6? Positive 66. Okay? Does this make sense? Why put minus negative when you could just put plus? Do you understand what I'm talking about? Sure. Thanks. When I'm done completely, you'll come back and finish these, but I think you're good because we have done distributive property before. So let's move on to the next page. Simplifying algebraic expressions. This is huge. You will hear this vocabulary. You've probably already heard it, and maybe you weren't so clear on what it meant. A term. You'll hear us say terms of the expression, or what terms go together, or like terms, combining like terms. A term is a number. It can be a variable, or it can be a product of a number and a variable. It's terms and expressions that are separated by addition or subtraction signs. So that's one term of this expression. The negative b is another term. Positive 2/8 is a third term, and negative 7 is the fourth term of that expression. There's 4 terms in that expression. Coefficient. Fancy definition is the numerical part of a term that also contains a variable. in regular language, it's the number that's in front of the letter. It's the number in front of the variable. So the coefficient is 6. What's really in front of this b? What number is really there? -1, thank you. Because it takes the sign of whatever's in front of it. So the coefficient here is -1, and the coefficient here is 2. So the coefficients are 6, -1, and 2. The constant. Well, first of all, what's a variable? It's something that can vary, right? A could be 2, A could be -6. A constant can't change. It's constant. It's not going to change. So your constant is your plain old number. It's just the term without the variable, just a number. So your constant here is -7. And like terms, this is what we're going to really work on today. Terms that contain the same variables. And when I say same, I mean exactly the same. 6a is not a like term of 6a squared. You have to have the exact same variable makeup to be like terms. So that's a plain a, that's a squared. You can't put those together. If you had 6a and 6ab, you cannot put those together. Now 6a and 7a, you could add or subtract those depending on what they want you to do, because they're exactly the same. Say you had, sometimes they try to trick you. If you had 12 x squared y and then maybe like a 14 xy squared, these are not the same. These are not like terms, because here the x is squared and you have a single y, but here you have a single x and a y squared. Not the same, you can't add or subtract them. Alright? So when we're talking like terms, they have to be exactly alike. So what we're going to do is identify all these things. But we're going to try to make this into like a nice little chart so we don't have to write these words over and over. So off to the side, I'm going to write terms, like terms, and you can do this too, coefficient, and constants. And then I'm just going to draw a line across and maybe make like a grid so we don't have to write this over and over and over again. And as always, stop me if you have questions. I'll give you a second to get that written down. So the terms are each thing in the expression separated by the addition or subtraction. So our terms in number 1 are 2, 6a, and 4a. There's 3 terms in that expression. Now, like terms are the things that we could actually add or subtract, the 2 things we could put together. Well, it could be more than 2. It could be, 3 or 4. So what could we put together here? What 6a and 4a. The coefficient is the number that's in front of the variable. So we have 6 and 4 because that's what's in front of each a. And what is our constant? 2. So far, so good? Questions? Yes?
So we don't actually solve it, we just identify it.
Correct. We're not combining like terms yet. We're not simplifying it. If you did simplify that, it would be 2 plus 10a or 10a plus 2. But we're going to do that on the next page. Here, our terms. We have m, 4m, 2m, and 5. What are our like terms, meaning we could add them together in this case? Say the first one again. 1m. Yes. We could put 1m with 4m and 2m. Always remember, if it's a single variable, it has a 1 in front of it. And if it's a negative variable, that means there's a negative 1 in front of it. This is a big concept that comes up over and over again. And some students struggle with that idea. What are our coefficients? Well, if we wrote 1m here, then we better put a 1 here. So 1, 4, and 2. And your like terms can be constants. I mean, if you have two constants in something, you could put those terms together. And what is our only constant, though? 5. Questions on that one? Yes?
So, like, if we're going to add this together, would we add the 1?
Yes.
Why would we add the 1?
Because there's one of them there. You can't forget about it. Right? So it would be 7m plus 5. Make sense? Because that actually counts. So our terms in number 3. 3c. What's my next one? 4d. What's my next one? Very good. Negative 1c. Now, if you just put negative c, that's fine, but you have to recognize that whatever is in front of the number, whatever comes before the term, that's the sign that goes with it. You don't have to put the 1, but I think it helps when you're trying to identify coefficients and you're just starting this. I think it's helpful for you. And then finally the 2. This is a c. It looks like an e. Our like terms are 3c and negative 1c. Nothing else has a d in it, so there's nothing else like it. Just like you. Well, there's something kind of like you. I mean, you are a twin, but you're still, fraternal, so. Coefficients. 3, 4, and negative 1. Negative 1. Make sure you have the negative. That's why this is a good one to do. And it is possible not to have a constant at all. If you look at number 6, is there a constant in number 6 at all? No, so you just write none. But with this, number 3, what is our constant?
Is that a constant?
No, I said number 6, there's no constant. But here, our constant is 2. Yes.
For some reason, that was number 6 in my head.
Oh, maybe just. All right. Questions on this? Next page. I will do the whole next page with you. Now we're going to put it all together. Yay! Yay!
Yes.
Hey, no homework and you have calculators. Yay! Okay. All right, there you go. All right. So we're going to put it all together. We're going to start out slow in the beginning. So number 1, we have 2m terms. So all you do is put 9 plus 3, which is 12, and put the m there. On the next page. And there are lots of notes above this if you want to go ahead and read them. It's the study guide and intervention is, more notes basically. 5x minus x. We talked about this just a second ago. What's really in front of the x? What is the coefficient of x? There's a 1 there. So what is 5 minus 1? This is 4x. And these are just expressions. We are simplifying these expressions. Number 3, everything has a y in it, so we can combine everything. They're all like terms. So you just take 8 plus 2 plus 3. 13y. Number 4, I have an m term here and an m term here, and the 4 is my constant. So I'm going to box my like terms. You could circle them if you wanted to, but I'm just going to underline the constant. So your brain starts to recognize, okay, this goes with this, because some of these will get really long in the future, and it'll help to, identify your like terms maybe with some sort of system. So what is really here? How many m's are here? 1, and then how many m's are here? Negative 3. So what's 1 minus 3? Negative 2, and I'm just, negative 2m, and I'm just going to put plus 4. Now, if you put 4 minus 2m, it's the same thing. What matters is the sign in front, that you got the signs correct. Because remember on the ACAP that you guys practiced last year, you took a practice ACAP, and it was really neat because there would be like, pick all the answers that are correct. Or you'd have the spaces, and you could drag your answers in and things like that. I thought it was kind of cool. So one of the things that we're going to start practicing more is recognizing equivalent expressions. The fact that this and this are the same thing. Okay, so maybe in the future, on the test, or when we do a checkup or something, it'll say, what are all the correct answers, or choose all that apply, or choose all the possible correct answers. So there could be more than one correct answer now. All right, number 5. Can we see this? Yes. We have a negative 15e, and we have a negative 5e. So I put boxes around those. And then I'm going to underline my positive 7 and my negative 9, which are my constants. Ooh, there it goes. Okay, so like boxes go with boxes and underlines go with underlines. Like, you know, when you were a little kid and you had the thing and you put the shapes in and you couldn't put the square in the circle. Or Perfection, the game that would pop and explode if you didn't get all the pegs in the right spot. Did you guys play that?
Yes.
So fun.
It is fun. It's also stressful though.
Maybe I'll bring it in. All right, so we have a negative 15 minus 5. This way you have your calculator, just in case. I don't think you do, but what is negative 15 minus 5? Maybe you do need them. Negative 20. Maybe you do need that calculator.
You use the calculator.
Oh, please autofocus. And then what is 7 minus 9?
Negative 2.
Thank you. Negative 2.
Can't we just put this all in our calculator?
No, you cannot put variables and all this in your calculator. Plus, I want you to be smart, not your. I don't want your smartphone or calculator to be smarter than you.
That's what its job is.
Nope, you guys are smart. Alright, so, look at number 6. Now we're getting into distributive property, and then we have to combine like terms. So we're going to distribute the negative 8. So we have negative 8r, then what? Minus 48. And then you just recopy the rest. Minus 4 plus 1. Again, you might say, can I put plus?
You said 4.
Minus r?
You said 4.
Minus r plus 1? Sorry, minus r plus 1. You might say, can I put plus negative 48? Again, you don't need the double sign. So now we can put together our like terms. So we have a negative 8r and a negative r, and I'll underline my constants. And go ahead and tell me what that will be. How many r's are there? Negative 9r. Minus 47. Subtracting a positive is the same as adding the negative. And this is simplified. This is as far as it goes. Here, we have to distribute what? Because that way it's not everything everywhere. Well, I'll think of something and get back to you as soon as I'm done with this. What are we going to distribute here? He said negative 9. We have to distribute a negative 9. So we're going to recopy negative 12c plus 3. And that, what will we have? Minus 99 and plus 9c. And now we're going to combine our like terms. We have a negative 12c, a positive 9c, and a positive 3 and a negative 99 go together. So what do we have?
The problem.
Negative 3c?
Yes, plus negative 96.
Yes, minus 96. Again, if you put plus negative 96, I know it's the same thing, but simplified as possible. Okay, think about life. Why wouldn't we simplify things if possible? Like, would you, if you're going to the nurse, would you go all the way down this hallway and all the way down that hallway and then back around and go by the office? And would you, no, you go the simplest route.
Why would we put a variable in the distributive property? That's why I like
You're
it.
just like rewriting the exact same problem.
Okay, so we will see then when we go to do those problems where I present different forms of this, if you can recognize that they're the same thing. So here we go. We're going to distribute the -8. This comes up over and over and over again in your math classes from now on. You'll be surprised at how much. And if you're struggling with this right now, it's new. It sounds like you guys are getting it, but next year you'll see this and it's like second nature. Or even in a couple weeks you'll be like, I don't know why I thought this was so hard. It's just because you're just learning it. So don't panic if you're kind of struggling. You're gonna work on this for a long time. So we rewrite 7h minus what? 16g plus 24h. So you finish that problem. See what you get.
You want h minus 16.
Do we agree? H's go together. They're both positive. And then minus. And if you put this, because sometimes, you know, if it's in alphabetical order, the variable terms, this is the same thing. Same thing. All right, you go ahead and try number 9 on your own, distribute, and if you want to do 10 as well, and then we'll check to see how you're doing. What is the second line? What do I write next for number 9? -6n plus 12p plus 6n. What do we notice? What do we notice about this?
You're gonna have 0.
0. You have 0 n's. What's 0 times anything? I don't care if anyone's a million or 2. You get 0, so you don't write anything. The answer is 12p. That's it. And here, again, you don't read right to left, you read, you don't read right to left, you read left to right. So the 5 is not negative. That goes with the 12. That goes with the 12f. So when we distribute the 5, it is -10f plus 5e minus 12f. That is an e. It just looks weird. Combine like terms. And what do we end up with? Sir? -22f plus 5e. And what's another way if I wanted to write that? How could I write that?
5e plus -2f.
2.
5e minus 22f plus a negative, same thing, but we want this as simplified as possible. All right? Any questions?